Howdy folks, Mr. Koffler here with a quick lesson on how to calculate frequency, wavelength, and energy of light. So, I pulled this question from the homework I assigned. This is question 7 on the back, the last question. This is the hardest question because it requires you to use both of the equations that we've discussed so far. C equals lambda V, or C being speed of light equals wavelength times frequency, and the other one, E equals HV. Energy equals Planck's constant times the frequency of light. So let's analyze this question. The energy for a quantum or a particle of light is 2.84 times 10 to the 19 joules. So we have an E. What is the wavelength? So we have an equation with energy. That's what we were given. E equals HV. But it wants to know what the wavelength is. So step 1 is to figure out the frequency. So let's look at what we know. We know E. This is our E. And we know H. Here's H. H is always this number. It's called Planck's constant. It's a constant. It doesn't change. So, going to rework this equation in terms of frequency. So frequency would be equal to energy divided by Planck's constant, which would be energy from the question, 2.84 times 10 to the negative 19 over Planck's constant, 6.626 times 10 to the negative 34. Now let's switch over to my calculator. So I just plug that into my calculator. The energy was 2.84 times 10. Remember, when you're doing the scientific notation, you got to do second, comma, for that little e, that means times 10, and then you put in the exponent, which was negative 19. Then divide that by Planck's constant, 6.626 times 10 to the negative 34, which gives you 4.28614, blah, blah, blah. We don't care about that. We round it. Round it to the, let's say, the hundredths place. So when we round it to the hundredths, it would be 4.29 times 10 to the 14th. Remember, look at our answer here. Rounded this to 4.29, and E14 at the end here means it's times 10 to the power of 14. Now, we have a frequency. We have a frequency. My computer will speed up here. There we go. We have a frequency. But the question asked us for a wavelength. Now, how do we take that frequency and put it in wavelength form? Right here, this question, C equals lambda V, or speed of light, C. Here's C. So for part 2, let's establish what we know. We know C. C is 3 times 10 to the power of 8. I gave it to you right here. It's a constant. It's the speed of light. It doesn't change. And we know V from the previous answer. So, let's put this in terms of lambda, or wavelength. All I do is divide both sides by frequencies so as to cancel it over here and put it over here, so it would be c over frequency, which would be equal to 3 times 10 to the 8th divided by the frequency 4.29 times 10 to the 14. Let's go and put that into my calculator. So we have speed of light 3 times 10 to the 8th divided by the frequency we got before we rounded it to 4.29 times 10 to the 14, which gives us long ugly number, but use your rounding rules. Rounded to the hundreds, it would be 6.99 times 10 to the negative 7 meters. So there's our answer. 6.99. The wavelength is 6.99 times 10 to the negative 7. That is the answer for number 7. So let's walk through this one more time. We got an energy and it wanted wavelength. So step 1 was to find the frequency based on the energy. We used E equals hv, energy equals Planck's constant times frequency, and solve for frequency. Once we got the frequency right here, we plug that into our other equation. Speed of light c equals lambda wavelength times frequency v, and we solved for wavelength, which we came up with 6.99. I hope this clarified things a bit. I will see you in class.